over here, and this is the 1996 AIME problem number 2. For each real number x, let floor of x denote the greatest integer that does not exceed x. For how many positive integers n is it true that n is less than 1000 and that the log 2 of n floored is a positive even integer? So for this problem, what I think we'll do is we'll try a couple of cases and then establish a generalization, which will eventually solve the problem. Alright. So first thing is, well, when we have n equals 2, and when we have n equals 2, the first number where we get log base 2 of n floored equals 2 is when log base 2 of n is 2. Equals 2, so we can find out that from here n equals 4, and then we go all the way until 7, right? Because if we were to go to 8, then that'd be log base 2 of 8 is 3, so we're in a new integer. So now we go to 4, so that means that log base 2 of n would equal 4. So n equals 16, 17, and then we'd go on until n is 2 to the next power minus 1. So we go on to n equals 2 to the 5 minus 1, which is 31. Okay, now we're ready to generalize. So for a even integer k, even positive integer k, we want to, the first time we'll achieve a k is when log base 2 of n equals k, or from which n equals 2 to the k, and then we can also have 2 to the k plus 1, all the way until we have 2 to the k plus 1 minus 1. And then from here, we can clearly see that we have 2 to the k such numbers. Alright, so now we want to sum over this. So for n equals 2, we'll have 2 squared such numbers. For n equals 4, we'll have 2 to the 4th such numbers. For n equals 6, we'll have 2 to the 6th such numbers. And then maybe for n equals 6, those will be the numbers from 64 to 127. So for n equals 8, we'll have 2 to 8 such numbers. Those are the numbers from 256 to 511. And then after that, we reach n equals 10, which is from 1024, but that is a contradiction of this condition. So this is our answer. We can evaluate this of any method, so we'll just manually add this. 256, 2 to the 6 is 64, so we're just dividing by 4 each time. That's 16 and then 4. So we have 10, 14, 20, 22, 7, 13, 14, 3. So we have 340 and we are done.